Come once again to 4Keys Private Tuition. I'm your host, Say Shungu. You can contact me on the numbers shown on the screen. In this particular video, we're going to talk about acid-base reactions that are commonly referred to as neutralization reactions. So let's dive straight into today's lesson. Okay, we're also going to look at how you can create soluble salts using insoluble bases such as metal oxides, metal hydroxides, and metal carbonates. Okay, so we have the following general equations. When you mix a metal oxide, which is a base, with an acid, you get salt and water. When you mix a metal hydroxide with an acid, you also get a salt and water, and these are neutralization reactions. So as an example, you have hydrochloric acid plus your sodium oxide. You get sodium chloride, the salt, and of course your water. And you need to balance these equations each and every time. So when you use a metal hydroxide instead of an oxide, you're going to form here, if we use sulfuric acid and potassium hydroxide, we are going to form our potassium sulfate and water. So you need to take note of what's common here. Every time you react an acid with a base, in order for you to form the salt, the general equation says here the acid plus the base, you get salt and water. So you see that every time you get the anion from the acid. So you need to memorize it that way. In order for you to create the salt, you get your anion from the acid. So in the first example there, we had our chlorine minus ions from the HCl, which combined with the cation from the base. So just try to remember anion, acid. So of course the cation in most of the cases is going to be a metal, which comes from the base. So that's how we got our sodium chloride. In the second example, we got our anion and the sulfate from the acid, sulfuric acid, and we got our cation, which is the potassium ions from the base, and we got our salt, potassium sulfate. So just try to remember that. That is how you create the salt. Okay, and of course you get your water. Right, so let's move on and see. It's also important for you to remember to balance the equations. Okay, we can also react acids with carbonates that are also bases, but in this case we're going to get different products. We are going to get our salt and water plus carbon dioxide gas, so you need to remember that. For example, if we reacted nitric acid here with calcium carbonate, we would get of course our cations from the base and our anions from the acid as before to create our salt. In this case, the cation and the anion will react in a ratio of 2:1. We need 2 nitrate anions here to form our calcium nitrate, which is the salt, plus water and carbon dioxide. And of course you need to balance. So far the salts that we've been looking at are soluble salts. They're going to dissolve in water. It's important to know, for you to know which salts are soluble and which ones are insoluble, especially when you would like to create or write ionic equations. It's important to know which ones are going to dissolve in water. You may use this information here that the salts that we have so far are soluble. Okay, and you can create these soluble salts from insoluble bases such as metal hydroxides, metal oxides, or metal carbonates. Okay, so let's look at an example here. You would need your acid, your dilute acid, and for example here we have dilute HCl, and you're supposed to heat it gently, and then when you heat it, what happens is that you have to add your base into the hot acid, and as you continue to add, you realize that some of the base will no longer disappear, meaning that your reaction or your acid has the molecules of the acid that you had have come to an end. So if you continuously add the base there, then your acid is going to be the limiting reagent. So there'll come a time when you won't see any of the base dissolving, meaning that all of the acid molecules would have been used up. So at this stage, what you have to do now is you filter off the unreacted base, the insoluble base. You have to filter it off, and you collect all the products into a test tube. So in this case, you would have collected all your soluble salt. So that's the soluble salt in the test tube there, which would be copper chloride in this case. Check with the equation here up there. Okay, so copper chloride, our salt, which is soluble. What we do next is we have to heat in a water bath so that we can evaporate off the water, and when we do so, we'll start to see some crystals forming into the beaker, and at that stage we stop heating and we leave our solution to cool off, and then we filter off the crystals that we get. Those will be the crystals of the salt, and we dry our crystals, and of course we can just leave the filter paper somewhere warm in order to dry off our crystals. So this is how we would create a salt, a soluble salt from an insoluble base and an acid. So I want you to remember that we did a video where we were looking at how you can also calculate the number of moles or the concentration rather of an unknown using titration reactions. So these acid-base reactions are common in titration experiments. So this is an example of the information that you might get from a titration experiment. Here we are told that 30 cubic centimeters of 0.5 moles per cubic decimeter of potassium hydroxide reacted completely with 25 cubic centimeters of sulfuric acid. So that's an acid-base reaction there, in which you form a salt and water. So the question says work out the concentration of the sulfuric acid. So the information that we're given here, we're given the volume of the base, the concentration of the base, and the volume of the acid. So this is the information that you get from your titration experiments, which are also referred to as volumetric analysis experiments. So you get the volumes. You have 30 cubic centimeters for the base, 25 cubic centimeters for the acid, and you are also given the concentration of the base. So the question is calculate the concentration of the acid. So you do so in 3 steps. I urge you to go and watch that video. You work out how many moles of the base that you had in the beginning. In other cases, you may be given the concentration of the acid, so you have to work out the concentration of the number of moles of the acid first. But in this case, we're going to use the base, and then you use the molar ratios to determine how much of the acid would react with those number of moles of the base. So let's see that for our potassium hydroxide here, we had we are going to say number of moles is equal to concentration times volume. So we have our 0.5 for the concentration, and our volume is 0.03 cubic decimeters, which will give us 0.015 moles. So according to the molar ratio there, we require every time we have 2 moles of the base, we require 1 mole of the acid. So we require half the number of moles that we've calculated for the sulfuric acid. So we divide by 2 there to get 0.0075. And of course, now that we have the moles, we already have the volume, so we can simply say concentration is equal to number of moles over volume, which will give us 0.3 moles per cubic decimeter. You can watch this video. I did a video for these calculations earlier on. You can check it on my channel. So I'll see you in the next video.